Managing industries at sea has never been simple. Far from land, across multiple jurisdictions, and costly to enforce, the ocean is one of the hardest places in the world to manage. But new technology is allowing us to watch the ocean like never before. Still, innovation comes with trade-offs. As artificial intelligence expands, questions are emerging about its environmental footprint, from water and energy use to the possibility of jobs being displaced. So how do we balance these risks with the unprecedented potential of technology to improve ocean governance? This is Ocean Intelligence, a natural justice series exploring how data, AI, and science are reshaping the world of fisheries and aquaculture.
Jordan and Trond, welcome to the Natural Justice Podcast. I'm very excited to have you both here today and to talk about your company, Actea. To get us started, Jordan, Actea emerged from your experience building technology startups. What inspired you to really work at this intersection of technology, AI, and ocean science?
Hey, thank you for having us, Eva. So I studied computer vision at Caltech for my undergrad, and then my career kind of took a detour onto Wall Street. And then I got back to my roots doing computer vision at a tech startup I co-founded in 2012 called Reality Cap. After we sold that company to Intel and we took our kind of startup product and moved it onto an Intel platform, I wanted to get back to what I saw as a kind of very interesting area of technology development, which was called multimodal machine learning. And just like in visual inertial sensor fusion, we're combining these different types of information to come up with a new picture of the world. I was interested in what other types of data I could apply that same thinking to. And at the time I was thinking about what direction to take that, I met Trond.
Trond, you come more from quite a different background. You're a climate oceanographer. What made you decide that some of the science that you were working on, maybe more in an academic setting, that could also be valuable for commercial application?
Yeah, well, nice to be here. Thank you for having us. I think it started a few years ago. Like I've been working on the interface between oceanography and species of the oceans and trying to understand how climate change and climate variability is actually impacting different species. And throughout that work, I've been doing modeling basically. And so I've been using this typical approach for modeling the ocean, which is dynamic models. The problem with dynamic models is that they're extremely good, but they're also very time consuming to set up and configure for a given region. So if you want to understand how climate change is impacting a certain area of the world, for example, you can spend 2 years setting up a dynamic model. So as part of a research project I did a couple of years ago, I realized that we need a new tool for doing this. We need something that's faster, that allows us to actually understand how climate change is impacting species habitats along the coast. And we need to do it in a way that is applicable and fast. So I came up with a methodology which sort of combines different statistical approaches and machine learning to produce these kinds of data much faster than typically has been done before. And I realized that this is something that you not only need for the coast of California, or the coast of Norway, you need it everywhere. So how can we actually scale this up and provide these kinds of solutions anywhere in the world for any kinds of species or any type of approach that you want to learn more about how the ocean is actually changing and the climate change?
Yeah, actually, also one of the, I have a completely third different background from both of you, as I'm coming more from a legal background. But one of the things I really love in working in the ocean space is that people from different specialities really do have to come together to ultimately tackle some of these challenges that we're having and provide those solutions like the technology that we'll be talking about today. So to get us started, how would you introduce Actea and its value if you'd have to do it in an elevator pitch? So I'll give you roughly 30 seconds to do that, just to give us some highlights.
The ocean is vast. There is not enough data recorded about it, but there still is a lot of data on the ocean. And people often have a regulatory or a business need, but they don't have the right data. And what Actea can do is it can take the existing data and transform it to answer the business or regulatory question at hand.
I'd like to dive deeper into different elements of this. So first, I would like to talk about climate change. Maybe, some of our listeners are not exactly clear on how climate change is already impacting our oceans. So maybe I would ask to start to explain how climate change is impacting the oceans, and then with the models that you're creating, how we can actually use this information to predict the impacts that it's going to have on fisheries.
Yeah, I mean, the climate change is impacting the marine ecosystems in a variety of different ways. The ocean is warming. That means that there's less oxygen that's soluble in water. So you have reduction in oxygen at the same time. Because we're releasing so much CO2 into the atmosphere, a lot of that CO2 is taken up by the ocean, which increases the ocean acidification.
Mm-hmm.
So when you have changes in oxygen and you have changes in temperature and pH at the same time, you have multiple stressors that are basically affecting all of the different life stages and the different species that we have in the ocean. So the ocean is severely affected by climate change, I would say.
And, going back to what Actea does, when people model the shift in climate change, I don't know how familiar your viewers will be with this, but I'm sure they've heard in news stories about the IPCC and the kind of periodic reports on what's expected and different scenarios into the future of emission scenarios. The calculations that are done in order to kind of provide the scientific basis for that work are not done specifically to study the ocean. They're done to kind of understand larger climate trends. So if you take data that's from a class of models that are public models, public domain government data called the CMIP-6 models for Climate Model Intercomparison Project 6th Generation.
Helpful.
The CMIP-6 models are very low spatial resolution in the ocean. And they have kind of, they're not exactly what the real world is, right? So if you want to ask the question of, can you from this climate model understand the impact in this place for this species of fish? The answer is not directly. The first kind of set of transformations that Actea does is taking what we call non-biased high resolution data. So that's actual observations from the ocean, from a satellite, or it could be a high resolution historic computer simulation. And we learn a transform from the historic period of a CMIP-6 data set into that unbiased high resolution data, which is useful for answering questions about fish. We do that for the region of interest, for the species of interest, to understand very precisely how we expect climate change to impact habitat.
You say non-biased. What is normally the bias?
Yeah, so if you ask these CMIP-6 models what temperature a place in the ocean is today, they might disagree with each other by a degree and a half.
Mm-hmm.
They all kind of broadly agree on the trends that it will get, a degree and a half warmer over time, or 2 degrees or 3 degrees. They are all kind of different theoretical Earths. They are not the actual Earth. So the bias is just the disagreement in the expressed temperature in one of these models versus at this location versus what you've actually observed at that location.
Could you maybe also give an example of a past project that you've done, and maybe where also, having this information then has led to different decision making, whether it being by a government or a company?
So there's a visual that we can share here, which is a snow crab habitat off the coast of Alaska.
Yeah, we have multiple examples actually where our data and analysis have had an implication for how you do long-term strategic planning, for example. One thing that we're sort of proud of is that NOAA has purchased our data to understand how climate change is impacting different species in the Gulf of Alaska and the Bering Sea. Those data are used for long-term strategic planning and management. And then 2 years ago, we also provided all the data for a huge analysis that was done by the Norwegian Environmental Agency in Norway, where they wanted to understand how the key commercial species along the coast would be affected by climate change and the different climate scenarios. So using our data, we could then calculate what is the distribution of, for example, coastal cod or the southern part of Norway under warming. Cod in that particular region is very much affected by the warming, and it may actually cease to exist in those waters. And then we're looking at other different species, such as kelp, for example. Kelp is such an important habitat for different fish species and other marine life. How is kelp going to be faring under climate change for the coastal waters of Norway? We also had, we provided all the data for the huge EU project called Future Mars, where we provided climate data for all the waters of the North Sea, the Baltic Sea, the Mediterranean, and the Bay of Biscay. So that was really fascinating to see how hundreds of scientists actually used our data in order to understand what a variety of different consequences climate change may have in these waters, and what sort of solutions you may actually apply in order to mitigate and adapt to climate change that is happening.
Such an important topic with, also from my background in law of the sea, a really big challenge that we have, and that's only going to get bigger, is with these different fish stocks kind of moving to different areas, and then, okay, who has the right to fish them? And there's not necessarily one clear answer to that. There's kind of historically different ways that we've had of determining that. And I think what I really like about, what I hear from your technology is that it can really allow the decision makers to shift from being very reactive to what is happening now with a lot of climate issues, not just this one, but I think more broadly, whenever we're talking about responsible fisheries or sustainability, to actually being a lot more proactive. We can't really say with these technologies that we didn't know, right? There is that data, and it's not just the data of what's happening now, but if I hear it correctly, it also means that you can much better predict what is likely going to happen. A related topic that I wanted to ask you about is carbon removal projects. Could you explain what these projects involve and how this is also part of your work?
Absolutely. So earlier, Trond mentioned ocean acidification as one of the main consequences of climate change. So broadly, when we drive a car or, natural gas is burned to produce electricity, carbon dioxide goes into the atmosphere, but the atmosphere and the ocean breathe with each other. And so about 1/3 of all of the carbon we've put into the atmosphere has already made its way into the ocean. And there's another visual that we shared where you can see that historically versus, the pre-industrial time, ocean pH has already materially come down. We're already seeing impacts both in wild fish and also in aquaculture, where, for example, in aquaculture, a place called hatcheries, they've had all of the larvae die because the water's been too acidic that they've taken in. So they're starting to have to add buffering to protect the larvae. And what that buffering is it's something called alkalinity. So it's adding a base to bring the pH back up as acidification brings the pH down. And there's what's group of scientists and kind of interested parties who have seen the ocean as a place to potentially store more carbon. So as the ocean is already naturally drawing down carbon from the atmosphere and becoming more acidic, if you add base back to the ocean, these days it's called alkalinity enhancement, although there's some debate about the name. If you add base to the ocean, you shift the ion that the carbonic acid is to something called carbonate or bicarbonate. And you kind of make space for there to be more carbon in the ocean. So you can simultaneously both cause more carbon to go into the ocean, which stops it being a greenhouse gas, and also buffer ocean pH prior to the reequilibration happening to protect certain, especially the larval stages of fish and marine life. I think that it's both a promising and a controversial topic because I'm not the lawyer, but I've heard there's something called the London Protocol here. You're probably more familiar with it than I am, but there's debate about whether or not marine carbon dioxide removal or sequestration is a violation of the London Protocol. Does the London Protocol need to be amended? But from our perspective, looking at the acidification which is underway, and this acidification, there is very little scientific debate about.
Mhm.
You can come up with different climate models, predict different amounts of warming under the same emission scenario, but they almost all predict the same amount of ocean acidification. So we are in store for a much more acidic future ocean, which is going to have very negative impacts on marine life and
Yeah,
aquaculture
sure.
as well.
Yeah.
So I think that there's a kind of, we're building a bridge between our analysis of future fish stocks, future aquaculture, habitat potential, and marine carbon dioxide removal to try and understand how all of these things can work in conjunction with each other in the ocean. We think that these questions all have to be answered together. You can't answer, should we do marine CDR without looking at the future of ocean acidification and how that's going to impact both the wild capture fisheries, ecosystem services broadly, and then also the aquaculture industry.
Yeah, because if I understand correctly, why there is also some controversy here is because, yes, the ocean takes up a lot of carbon. It's, what they call it, a carbon sink. I've heard of many different projects where they're trying to even kind of increase the capacity of the ocean, like farming a lot of seaweed, for instance, which is also great at carbon sequestration. But we, of course, also don't really know the impact if the ocean is going to have, because it doesn't just disappear, I guess, right? Is that kind of where the controversy comes from?
Well, I think it depends on who you're talking to.
As always.
Very quickly evolving field. There are many different strategies for marine carbon dioxide removal. They can broadly be categorized as kind of biological or abiotic or non-biological. And I think that there's different levels of scientific consensus about different of these types of these technologies. So for example, one of the most cost-efficient ones is fertilization of the surface layer of the open ocean, and it causes huge plankton blooms. And then biomass sinks, it takes all the carbon that got fixed through photosynthesis down to the bottom of the ocean with it, right? But there's, I think, big unknowns as far as, okay, well, the floor of the ocean it's the part of the ocean we know the least about because it's the hardest to observe. And it's a very low oxygen environment, but it's not a no oxygen environment. And if you dump a bunch of food down there and it takes oxygen to eat this food, what do you do to the whole ecosystem, right? And so that I would put in, this is me as an outsider. That I would say there's low consensus about, where there's other, chemically simpler forms of alkalinity enhancement where you just directly remove aqueous CO2 from the water, or you just directly add, alkalinity. And I think they don't rely on this kind of storage of biomass in the deep ocean. And I think that those are simpler approaches, which there is starting to be more consensus that they're kind of could be safe and effective. Do you think that's fair, Trond?
I think so, but a lot of the CO2 that you extract from the air is also then stored in the seafloor, in the rocks. Yeah, I don't think I have a strong opinion as to what is the best approach for removing CO2, but I do think that the co-benefits of doing MCDR using ocean alkalinity enhancement together with relaxing the ocean acidification is very promising.
And our tool, just to be clear, doesn't answer some of these kind of foundational questions about does this stuff ultimately end up? It's much more looking at the kind of operationalization of it, right? Like if you here, this is what we expect the ecosystem impact to be locally over the next 5 years, right?
Yeah,
and that
exactly.
we have a very good handle on.
Yeah, which is a position I also often take in the sense that I'm not necessarily saying we should do this or that. I'm not going to pretend like I have all the solutions, but here's my legal analysis of where there is some risk and where there isn't.
Right.
Making sure that everyone is informed is an important part of the solution, and it doesn't need to mean that you need to always be pushing for, are we going left or right with this? And we also recently had a episode on deep seabed mining, and just with anything that relates to the seabed, especially, the deeper you go, the less we know, and we don't know what we don't know. And that's really the big discussion with a lot of these things. I would also like to talk to you a little bit about aquaculture, because your work also extends to aquaculture. But before that, just in everything we've discussed here, does AI play a role in this work? And if so, how?
I'll leave that for
AI is a fuzzy word these days. Let me put it that way.
Sure.
So we use large language models that hallucinate? No, we don't. Do we use machine learning techniques which are now bundled in with AI? Yes, we do. At the core of all of these technologies is Bayes' law. I don't know how much you want to get into statistics on this. Essentially, it's conditional probabilities based on observations, right?
Mm-hmm.
And that is the entire thing that we do. We come up with a hypothesis about an unanswered question using the information we have in order to try and understand the expectation and variability of the question of interest, the thing we haven't observed, right? And Bayesian inference is kind of the key behind all AI ML technologies, and it's the key behind what we do.